All right, so this video is looking at whether or not something is, whether or not it responds to a magnetic field. First off, let's take a look at the DQ from last class. I asked you to draw the electron configuration for SC, the atom, and then its ion. So let's do the atom first. That's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then the D block lags behind, so that would be 3d1. And then the ion here would be 3 plus because it actually has the capability of losing 3 electrons to achieve the configuration of AR. So it's going to be the same thing here, but it's going to end with these empty orbitals. Okay, so just wanted to review that. So now what we're going to do is take a look at some elements and decide whether or not they're paramagnetic or diamagnetic. So before we do that, we want to be reminded that S has 1 subshell in it, P has 3 subshells, and D has 5 subshells. And when we put electrons in those subshells, one is always spin up and the other is spin down. And if there's more than 1 subshell, they're going to stretch themselves up first. We talked about a trick for remembering that in class. And then they are going to pair up if they have to. And something is paramagnetic if there are electrons that are left, like let's say this one, unpaired. And that means it is drawn towards a magnetic field. If the electrons are all paired, it is called diamagnetic, and it is not drawn towards a magnetic field. So diamagnetic, okay, we can think of it as the magnet dies. They're all paired. And paramagnetic, you can think about that as the magnet being, okay, pulled towards, or the electrons in the atom being pulled towards a magnetic field. So they're not paired, or not all paired. So let's look at an example. So an example here, we could look at, let's say, chlorine. Okay. So chlorine. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5, and we're going to draw those this way. 1, 2, 3, 4, 5. So it does have this lone electron, so it would be pulled towards a magnetic field slightly, so we'd call that paramagnetic. Now let's compare chlorine to, let's say, phosphorus. Let's go ahead and do phosphorus. So P. 1s2, 2s2, 2p6, 3s2, 3p3, 1, 2, 3. So all 3 of these will be drawn towards a magnetic field. So when you compared P and Cl, they're both paramagnetic, but P is more paramagnetic. Now let's look at something like Cd. So for CD, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6. Okay, there are no lone electrons here. They're all paired up. So in this case, this is diamagnetic, and it will not be pulled towards a magnetic